Like all parts which are mounted hot, this ring is fitted by hammering during the cooling off period. The second spacer ring is placed at the outer side of the shaft and fixed by hammering. The inner Seeger ring is placed without fixing. The ball bearing, which has been heated in the oil bath, is slid on. The heated inner ring of the cylindrical roller bearing is next. Both parts are fitted by hammering during the cooling off period. The bearing surfaces must not be damaged during this process. The outer pre-assembled bearing body is now slid onto the ball bearing and the bearing ring. The bearing body is locked with the inner Seeger ring. The shaft is removed from the mounting fixture with special hoisting apparatus. At the gear case, the seat of the inner shaft bearing is lubricated with oil. Two guide bolts are screwed into two flange bores situated opposite each other. And the pre-assembled inner bearing body is fitted in a way that the return oil bore is situated below. The bearing body is driven in carefully and with an even distribution of power. The guide bolts are tapped off. The bearing body is screwed to the gear case with 8 hexagonal socket head bolts, which are locked with fan discs. The bolts are tightened with a torque of 40 Newton meters. The pre-assembled vibration shaft is now introduced into the gear case. Here too, the return oil bore in the bearing body must be at the lower side. Two threaded bolts serve as guides. This adjusting process must be carried out with particular care. While being inserted, the shaft is turned and centered by a second man. The bearing cover and shaft are driven in carefully and with even distribution of power. The guide bolts are tapped off. The bearing body is closed with 8 locked socket head cap bolts. The bolts are tightened with a torque of 40 Newton meters. The bearing play is determined with a measuring gauge. At both sides of the unit, there must be a minimum play of 0.03 millimeters. The adapter for oil lubrication of the vibration shaft bearings is sealed in with Loctite 642. The second tap hole under the vibration shaft is closed with a blind plug. The assembly of the vibration shaft is finished. The squeeze cylinders have two basic tasks: transmission of movement from the vibration shaft to the pick arms, and positioning of pick arms during the tamping process. First, the pre-assembly of a squeeze piston. Two glacier bushes are fitted into the piston rod. This pair of glacier bushes is reamed with an adjustable guided reamer to the required inner measurement. Chips are blasted off, and the inner measurement is checked with a control bush. The piston rod is secured in a locating fixture on the bench. The sleeve for the cover of the squeeze cylinder is covered with a thin layer of Loctite 601. The sleeve is inserted in the cover in a way that one of the 4 recesses in the piston rod sleeve is directed towards the flat front side of the cylinder cover. Now the sleeve is fitted. A cylindrical pin is driven into the bore in the piston rod. The O-ring is placed in the wide groove at the inside of the piston rod sleeve. Together with the step seal. An O-ring is placed at the outer side of the sleeve. The scraper ring is inserted into the sleeve. The sliding surface of the sleeve is lubricated with oil. The transverse section once again shows the sealing arrangement, and particularly the situation of the step seal. The cover with the sleeve is slid onto its site. The piston, which has been heated in the oil bath to a temperature of 100 degrees Celsius, is placed on the piston rod with the bevel upwards and carefully fitted. Important: the cylindrical pin in the piston rod must enter into the small bore in the piston. After the piston has cooled off, the piston bolt covered with lubricating metal is twisted in. The piston bolt must be tightened with a torque of 700 Newton meters. The piston is counterbored through the tap hole in the piston bolt. The drilling chips are blown off. A threaded pin with hexagonal recess is screwed in to protect the tightened piston screw against torsion. The pin is tightened and protected against loosening by center punching. A mounting sleeve is placed on the piston, and the O-ring is put into its position. The grid ring, which has been heated in the oil bath to a temperature of 90 degrees Celsius, is slid over the O-ring. While the grid ring is still hot, it is restored to its original shape by means of a gauging tool. Two guide tapes are pre-formed. And placed into the upper and lower grooves in the piston. The aperture of each tape should be opposite the aperture of the other tape. The width of each aperture should be approximately 2 millimeters when the tape is tightened. The remaining 3 squeeze pistons are assembled in the same way. The cast part of the fork cylinder is attached to a swingable mounting fixture and laid aside. Inner and outer bearing rings are marked to avoid confusion during the mounting operation. The outer ring of the cylindrical roller bearing is covered with a thin layer of Loctite 601. And carefully driven in. The bearing cover is put into its location. And the spring washers are inserted. The bearing cover is screwed to the fork cylinder with 8 hexagonal socket head bolts. The bolts are tightened with a torque of 40 Newton meters. The fork cylinder is tilted to the other side. The second bearing is mounted in the same way as the first one. Now the fork cylinder is put in the upright position. The inside of the cylinder is lubricated with oil. The split introducing rings are introduced into the cylinder. The pre-mounted piston rod and piston are slid into the cylinder. The introducing rings are removed. The cover is mounted and screwed to the fork cylinder with 4 polygon socket head bolts which are locked with Schnorr-type discs. The bolts are tightened with a torque of 100 Newton meters. 2 fork cylinders are required for 1 tamping unit. For disassembly, 3 bores are arranged at the inside of each fork cylinder. The cast part of the outer cylinder, which is mounted on a swingable fixture, is laid aside. The inner fitting area of the cylinder eye is lubricated with oil. The outer fitting area of the bearing body is also covered with oil. The bearing body is driven into the cylinder eye. 8 hexagonal socket head bolts plus spring washers for locking purposes are inserted. And tightened with a torque of 40 Newton meters. The eye cylinder is tilted to the other side. The inside of the bearing body is lubricated with oil. The marked outer ring of the cylindrical roller